sequences. Arithmetic sequences are sequences that are going to have a linear vibe to them because they have a constant value that they're increasing or decreasing by. So that value is going to be what we call the letter D, and then it's going to be in the equation also as D, and we call it your constant difference. So this value is kind of similar to like a slope. That's what you're constantly increasing or decreasing by. Again, we call it the common or the constant difference, and so we denote it with the letter D. And again, these are going to look linear when you graph them, but if you remember, we talked about the difference between sequences and other things. And do we connect points when we graph sequences? Do we connect points? Do we? No. So it's going to look linear, but we don't connect points because remember that our domain is the set of counting numbers or natural numbers. So we're not going to include all the points, but it will appear linear like if you were to connect them. Okay, so this is our formula. A sub n, that means we can find any term n. Any term you feel like. But again, n exists in the set of counting numbers. So you're not going to have a value for n other than a counting number value or a natural number. A sub 1 is truly going to be your first term. N matches with this n, so whatever n you plug in also gets plugged in here. Subtract 1, and again, that's in parentheses. So thinking order of operations, we do that first, and then multiply it by the constant difference, or the common difference, whatever you would like to call it. All right, so here's an equation. Do you see how it's written in that form? All right, now, for this one, we want to find a couple things. We want to find the first 5 terms, so let's start there. So let's find a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. So that's step 1. Step 2, we want to find the constant difference, so we're going to figure out what that value is for D, and then C, we're going to graph eventually. Okay, so that's where we're headed with this problem. All right, so let's start plugging stuff in. If I plug in 1, 1 minus 1 is 0. 2 minus 0 is 2. So go through and find the rest of your values for me. I believe that you can do this without my help. So you find the other values. I'm going to push mine back up into the screen. So once you found your values, I want you to check them against mine. How'd we do? Good? Okay. What happened each time? How did your values change? They decreased by 1. So my constant difference is 1. If you're looking for it in the equation, remember the constant difference is either going to live out back of the parentheses or it can live out front. It can be either spot. It's mobile in that way. In this case, it's out front. Do you see how out front we have a negative 1? So that's the constant difference, and that's where we would find it. So when we go to graph it, we're going to graph in terms of the term number and then its value. So over 1, up 2. Over 2, up 1. Over 3, up 0. Over 4, down 1. Over 5, down 2. Again, we're not going to connect them because the in-between values are not included. So typically in a function, we include the in-between values, but in the sequence, we do not. So it's just the points it feels like you want to connect them, but do not. Another type of problem you could come across with these arithmetic sequences, again, constantly adding or subtracting the same number, is I could give you a sequence of numbers and ask you to come up with the constant difference, or even decide if it's arithmetic to begin with. Some of the sequences might not be, and when you look at them, you would say there's no constant difference because it's not arithmetic. So that's another option, like almost it's a trick question. So let's take a look at the first one. How would I navigate from -10 to -4? What would I do? Add 6. How would I navigate -4 to 2? Add 6. Am I adding 6 across the board for all of them? Yes. So is this arithmetic? Yes. So if you have a constant difference, then it's arithmetic. So yes, it is arithmetic. What's my constant difference? +6. So the sign does matter. So make sure you correctly put either plus or -6. Okay, let's play that same game with this one. How would we navigate from -2 to -5? -3. -5 to -11. As soon as you get numbers that are not the same, what do we say? Is this arithmetic? No. And we're not asking what is it, we're just saying is it arithmetic? So no, it's not arithmetic, and so we can't find the constant difference for this one. So the answer is no, and then we move on because there's nothing we can do in terms of a constant difference because there isn't one. All right. Some of the other work that we're going to be doing today is going to involve writing the equation. So that form that I circled up here, we're going to continually use this today. There are also things called geometric sequences, and we're going to talk about those in the next section. Geometric sequences are when you multiply by a number. So you constantly multiply by 2 or 3 or whatever. Okay, so arithmetic is constant addition. Geometric, we're going to see multiplication. So that's kind of the difference between those two, and those are the only two types that we're going to see. All right, so it's got steps for us. We're going to go through all the steps to help us find the first 5 terms and then also to find the 100th term. So we want to write an equation before we do anything else. Again, our equation is going to be in the form a sub n equals, we're going to have a sub 1 plus the constant difference. I like it when it's out front. So I'm going to write it like this with the variable out front. All right, so let's start by finding the constant difference in our sequence. How would we get from 11 to 8? 3. How about 8 to 5? Yeah. So we're subtracting 3 across the board, so what's my common difference? -3, so -3. All right, do you see how I have, so whenever they give you, by the way, and we say in math a lot of times, like, don't make assumptions, right? This is a time where we are going to make an assumption. If I give you a sequence, you're always going to assume it starts at term 1. So this is term 1, this is 2, this is 3, this is 4. What would be the value of term 5? -1, because I would need to go just one step further. All right, so we want to find the equation for the nth term. So we're going to plug into this formula. A sub n equals. The first thing I need is a sub 1. What was a sub 1? 11. Plus, what was my constant difference? -3. I regret putting the plus. You could put plus a negative. I'm just going to switch it to a minus, though. Times, in the parentheses, we'll have n minus 1. So the variable that does not get replaced with anything is the n. So you should always be replacing the a sub 1 and then the d for the constant difference. This is going to stay, and this n is going to stay. Good? Okay, so now I have my formula, and then it asks me to find the 100th term. So how could I find the 100th term given the formula? Plug in 100. So a sub 100 equals 11 minus 3 And then 100 minus 1 in parentheses is going to give me 99. So a sub 100 equals what? Negative 286. Agreed. Again, this is a spot where could you have, using the word I gave you yesterday, could you have brute forced it and gone all the way to find term 100? Like continued on just subtracting 3 to your, getting a little tired of it? You could have, or you can find the formula. Now, one other thing before we turn and go to the next page, if you would rather, you can switch this formula around so it's a little bit simpler. I'm fine if you leave your formula like this because that's the exact format we're working in, but you could also distribute the -3, right? And then add like terms together. So you can leave it like this, or you could go forward and say, okay, I've got 11 minus 3n plus 3, and then a sub n equals -3n plus 14. So this would also be fine if you want to move it over into that format. So this would be an okay answer, and so would this. I just want to show you that both would be fine with me. In some ways, I actually like this better, even though it isn't simplified, because you can pick out the first term, right? And you can pick out the constant difference. So I think there are actually some bonuses to this form, even though it isn't simplified. All right, when you're ready, turn the page, and we're going to do the same thing we just did, but with a new set of numbers, and of course they're fractions. Gotta throw some fractions in the mix. Okay. Let's think about our constant difference first. So we're thinking, how do we traverse from one of these numbers to the next? So what are you constantly adding or subtracting? 1/2. Ooh, I hear 1/2. 3/6. Do we agree we're constantly adding 3/6? Which would really be 1/2? I agree too. So if you look at how the change is happening here, we're adding 3/6 every single time, which is really adding 1/2 when we simplify it. So our constant difference is going to be plus 1/2. All right, so again, we make the assumption, term 1, term 2, term 3, term 4. How would I find the 5th term? Add 1/2. So we've got 8/3 plus 1/2. What do we need in order to add fractions? Yeah, let's get our common denominator. So I'm going to multiply this one by 2 on top and bottom so it can become 6. I'm going to multiply this one by 3 on top and bottom so it can also have a denominator of 6. So I get 16 plus 3, so that's going to give me 19 over 6. So my next term in the sequence, term 5, would be 19 over 6. How do we feel about that? Good? Then let's move on to our equation. So our equation is a sub n equals a sub 1. What's a sub 1? 7 over 6. Plus your constant difference. What's my constant difference? 1/2 times n minus 1. You can leave it like this, or you could multiply it out. That's going to get kind of ugly. I feel like this is one where I'm like, no, I think I'm done for today, right? Especially with fractions. But again, you can leave it either way on a test or quiz. I'm good with either. A sub 100, how would I calculate that? Yeah, plug in 100. So I have 7 over 6 plus, I'm going to have 1/2 times 99. So I've got 7 over 6 plus 99 halves. Can I add those together yet? No, I need a common denominator. What would be a good common denominator for this problem? 6. So I'm going to multiply this by 3, and if I do it to the bottom, I also have to do it to the top. So I get 7 over 6 plus, when I multiply here, I get 297. And then what should I do with those two top numbers? Add them together. And I get 304 over 6. So we do need to reduce. Do you agree we can reduce by dividing by 2? Okay. So we do need to reduce. However, I don't care how you leave your answer. You could leave it as a mixed number, or you could leave it as an improper fraction. If you leave it as a mixed number, it would be 50 2/3. If you leave it as an improper fraction, it'd be 152 over 3. And I'm fine with either answer. Again, I know sometimes I'm picky about stuff and sometimes I'm not. This is one of the moments where I'm very much not picky about it. For the last two problems, I'm going to use at least 2 different colors to help me understand what matches with what. I would recommend 2 colors, a pen, highlighter, something. Okay? So, you'll see why in just a second, because we're going to get some information. We're going to get a lot of information, and 2 things match up, and another 2 things match up. And so it's going to help me if I keep the things that match up in the same color. Again, if you don't feel like you need that in your life, don't worry about it. I just think it's helpful. All right, here we go. We've got 2 examples. They're very similar. The 8th term in an arithmetic sequence. So arithmetic, again, means we're constantly adding. The 8th term is 85. So a sub 8 is 85. So that's what I just took away from that. Then it tells me that the 14th term is 157. So a sub 14 equals 157. It would like me to please find the 5th term. So basically, in order to find a different term in this problem, I want to find the equation. Because once I find the equation, I can find anything, right? So we're going to go through and we're going to plug in. Now, do you see how our equation is in terms of a sub 1 and a sub n? We're going to have to make it work for what we've got, because do we have a sub 1? We surely do not. So I'm going to make this a sub 8 instead. So I'm taking the smaller one. Do you see how a sub 8 is the smaller of the 2? So take a sub 8, or whatever the smaller of the 2 is, and that's going to become your a sub 1. Then you're going to have plus, let's see what colors I want to use. I'm going to put the constant difference next. I don't know what that is, by the way, do I? No. And then in parentheses, I have, I'm not going to do parentheses yet, actually. Okay. I'm going to go over here and put my a sub 14 where a sub n is. So you always want to put the bigger number here where your a sub n is. This n is going to match to this n. So when I go to write my parentheses, instead of n minus 1, think about what n stood for. N stood for this. That means it stands for 14. Instead of 1, because the 1s are a match here, instead of 1, what would I put here? 8. So my formula is starting to take shape. So again, these should match, these should match. All right. Did they tell me what a sub 14 and a sub 8 were? Yes. What was a sub 14? Okay, so I'm going to plug in 157 in place of a sub 14. Did they tell me what a sub 8 was? 85. I'm going to plug in 85. And we know 14 minus 8 is going to leave us with 6. Now that I've plugged in, do I have enough information that I can solve for the constant difference? Yes. So this step, do you see how I have 3 unknowns? I can't do anything with that. I need to have a situation where I only have 1 unknown if I only have 1 equation to deal with. All right, so 157. I'm going to subtract over the 85. So I get 72 equals 6 times D. And then how would I finish to find the constant difference? Divide by 6, and so my constant difference is what? 12. All right, so I've got some more of my equation now than I had a minute ago. Have I figured out yet what a sub 1 is? No, that's problematic. So we want to go back now and figure out what a sub 1 is. In order to figure out a sub 1, we can use either of these facts to help us. So I think I'm going to pick a sub 8 because the numbers are just a little bit smaller. So a sub 8, which I have information about, is equal to a sub 1 plus the constant difference. What was the constant difference? 12 times n minus 1. What's my n in this problem? 8. Do you see how if I plug that in, do we know what a sub 8 is? Yeah, because I used something I knew. So 85 equals a sub 1 plus 12 times 7, which is something. 12 times 7. 84. And then how can I solve for a sub 1? Subtract the 84. And a sub 1 is what? 1. Not very exciting, but that's okay. All right, so let's write out our whole formula. We know all the things now. A sub n equals, so I'm going to make it generic. A sub n equals a sub 1, which is 1, plus the constant difference, which was 12, times n minus 1. So now do you see how I have everything in my equation? Now can I find a sub 5 pretty easily? Yeah, what do? Just plug in the 5. So 1 plus 12 times 5 minus 1, which is 4. So it gives me a sub n, or a sub 5 in this case, because that's what we found, is going to give me 49. So you always are going to want to go through and find the constant difference first, then work backwards and find term 1, and now you have your full formula and you can find anything you would like. Good? Is that okay? That one's a little tricky. Okay. Let's try another one. This one, we're given some more information. You can ignore the homework for a second, but obviously we're going to get there. So we're going to use this same formula, but instead of what they gave me an example for, now they're actually giving me a sequence. Where do I assume the sequence always starts? What do I assume about this? What term is this? A1. So this is A2, this is A3, and the question is, what term is this? So this term is A sub, I don't know. Let's find out. So, first of all, we know A sub 1. What's A sub 1? 23.5. So I can plug that into my equation. I also need the constant difference though, so let's find that over here. What is happening every single time to traverse from one term to the next? What's going on? Subtracting 1 1/2. Do we agree with subtracting 1.5? So now we know A1 and we know the constant difference, so we're going to plug into our formula that we've been using. AN equals A sub 1, which is 23.5. This should say plus, it doesn't. There should be a plus there, that's missing. Plus n minus 1 times our constant difference, which is negative 1.5. And again, you could put this out back or out front, it doesn't matter. All right, think about what you're given. We're given the value of the term and asked for the term number. Where does the 8.5 get plugged in to help me figure this out? There are only two plug-in spots. It's either here or here. Which one am I plugging into? A sub n. Because I don't know n. I don't know what term number it is, but I know that its value is 8.5. So this problem's a little bit different than the others. I'm going to move my 1.5 out front. So this one, I'm solving for n. If you came across this linear equation back in, I think, middle school sometime when we saw that originally, what would you do first to solve? Distribute, yeah, I like that. So let's distribute the negative 1.5 to both terms. 8.5 equals 23.5 minus 1.5n plus 1.5. Do you see how I can combine like terms? What's that going to add me up to? 25. So I'm going to go ahead and I'm going to subtract 25 from both sides. And that's going to cancel out both those pieces. So I get negative 16.5 equals negative 1.5n. How can I finish solving for n? Divide by negative 1.5. And n equals 11. What if n had come out to negative 4? Would that be okay or a problem? What if I had gotten n equals negative 4? Think about what n represents. Can we have a term negative 4? No. Could n have been 1.2? No. So when you're doing problems like this one, you can kind of check your answer a little bit and make sure that it makes sense. This should be a counting number. If it's not, you did something wrong. Okay? Because if you're searching for a term number, the only term numbers we have are counting numbers. How do we feel about all of that? Good? No one's giving me anything to go off of. We're okay? Okay. So you have some time to work. That's your assignment for tonight. We're going to finish up this section